Welcome you all. Hello students. Today I am going to discuss about Minkowski space. First of all, we will look to what is Minkowski space. Minkowski space can be referred as 4D world. You can get the first idea from Lorentz transformation. Before we know from Galilean transformation, T dash is equal to T. But when we came to know about the Lorentz transformation, we know that T dash is related to T, where T dash is the time in S prime frame and T is the time in S frame. So T dash varies. In a simple manner, I would like to say what is the definition of Minkowski space, then I will try to explain it very simply. Minkowski space. It is a combination of 3D Euclidean space and time. Before we know, we have the 3D space which contains x, y, and z, these three axes. And taking the time in also consideration, we can make a 4D space. This space has a special criteria. Here, the space-time interval between any 2 points is independent of the inertial frame of reference. So what does it means? It means if you take the interval in S prime frame or S frame, the spacetime interval will remain the same. Now we will discuss what is spacetime interval. Spacetime interval is a quantity that characterizes the relation between spatial distance and time interval that separate two events. This is mentioned in a physical language. Now, if you want to understand in simple mathematical manner, we can say that it is the distance between two points in 4D, like we have done in our junior classes. X, Y, Z are the coordinate of a point in three-dimensional space. We can take similarly 2 points in three-dimensional space, x1, y1, z1, and c t1. We are considering here the 4D space here. And another point in 4D can be taken as origin 0, 0, 0, and 0. So we can write the interval as in S prime frame, or let us say first S frame, del S square equal to x square plus y square plus z square minus c square t square. It is just simply the distance between origin and the point we have taken in previous. In S prime frame, we can write it x dash square, y dash square, z dash square minus ct dash square. If you use the LT, means Lorentz transformation, you will get the same value. So we can conclude that del S square is invariant. That's why we say that in Minkowski space, the space-time interval remains invariant. Let us now look at world line. World line is nothing, it is the path of that object which it traces in fourth dimensional. If we take two axes, along y we take ct and along x we take x. If we draw it for a photon, we'll get a straight line passing through the origin with slope equal to 1. Let us now discuss some important terms regarding Minkowski space. So far we have discussed what is the space-time interval, and now we will define some terms basis upon its value in some different regions. First, I would like to draw your attention towards O2P point. O is simply here. This is the O point at the origin. Now we'll first go to O towards P. This is your P point. You can see that here the slope is less than that of a wall line of a photon, which can be written as mathematically del S square less than 0. What it means? It means you know del S square equal to C del T square minus del X square. So it clearly means that your spatial interval is bigger than the time interval. That's why it is said as space-like. Now we'll go O to R point. First we have to locate the O point. You all already know that. Now we'll go O to this R point. If you go from O to R, you will clearly see that the slope is here is just that of the wall line of a photon. So if you calculate in this region the value of del S square, it will come out to be 0. That's why it is said as light like. If you consider this O2R line and move it like in a way to make a circle parallel to the rectangle shown here, you will obtain a cone in 3-dimensional. This cone is referred to as the light cone. Now we will discuss what is time like. Similarly, we will go from 0 O point to the Q point. Q point is shown here. If you look that in this region the slope is greater than that of a photon, so it clearly means that here the time interval is dominant over the spatial interval. So we can say it is the time like. This part you can say it casually connected, as here one event is connected to another. Now let us discuss what is future, past and present using this Minkowski space. For this I am discussing the future first. Let us go from O to D. The O you already have know. O and D. You can see clearly on going O to D, the value of CT increases. So we can clearly say that the time interval increases. It means the time value also increases. But if you go in this axis, there is no spatial change. Only the time is increasing. So this region 1 is referred as future. Now we are going to look the past region. Ongoing O2P dash. Now let us look where is O and OP dash. Here the point is O, the origin, and the point P dash is shown here. If you look these 2 points ongoing O to P dash, the value of CT decreases, but there is no spatial change. So we can refer that as the time decreases, it is the past region. Now let us consider the present region. We have to go to O to W for understanding the present region and region 3. Ongoing O is our origin and W is here. Ongoing O to W, we can easily see that the time is not going to vary here. What is varied here? Just the spatial coordinates. The events are occurring simultaneously in this region. So this region 3 mentioned here, region 1 also mentioned here, region 2 is also mentioned here. So the region 3 is the present region. That's all. I tried to explain it shortly and simply. Thank you.